This is going to be a video about doing a repair on your hot tub. It's important to realize that the voltages present inside of a hot tub, often 220 volts, can be deadly. If you venture into repairing your hot tub, you do so at your own risk. This video is going to be how to diagnose and repair, when possible, a pump assembly on a hot tub. Now, my particular hot tub is a jacuzzi J350. But this particular diagnosis process and repair process is going to be the same for any number of different brands and manufacturers of hot tubs. And the only difference is going to be, what particular exact parts you're going to have to order to do the repair, which are available at any number of online vendors. So it's pretty easy to get the parts. Most parts are pretty inexpensive. The main thing is the motor is the biggest expense on a pump assembly, and we'll get to that in a moment. But let's start with just the basic diagnosis. How do you know when your pump is bad, and actually how can you avoid having your pump go bad in a catastrophic matter? This particular model has two big pumps for the jets, and then it also has a very small circulation pump for the heating system, which is completely different in construction than these big pumps. So that's one of the two big pumps on this spa, and that's the other big pump on this spa. So on the high flow systems, every time the spa calls for heat, it has to run one of the big pumps on low speed. This pump is actually the original pump in this spa, and this spa is a 2003. So right now this spa is about 16 years old. So this pump had a pretty darn good run. If I'm not able to replace this pump and I have to replace the entire pump assembly, which I'll get to the nomenclature of that in a moment, the reality is I probably could have saved this pump if I had taken heed of a couple of telltale signs. The main symptom that tells you that you may potentially have a pump problem is water loss. Now, when a hot tub is running normally, because of the high temperature of the water, it's not unusual for water to evaporate. It typically will condense on the underside of your cover and drip back into the spa. When you're in the spa using it, that water goes up as vapor into the atmosphere. It's pretty straightforward. So it's not unusual over time to have to add some water to your spa. However, you tend to get pretty good at realizing how much water you need to add and how often you need to add it. So if you start to notice that you're having to add water more often than usual, or if you have any sign of a leak, for instance, if it's on a concrete slab and you see water standing on a warm sunny day around the perimeter of the spa, you've probably got a leak somewhere. So you need to investigate that leak. It could be any number of things. But what it could also be, or in this case what it was that the shaft seal on the pump had failed. So I'm going to go over the nomenclature parts description on this pump assembly when I get it out here and we can see it even better. But I'm going to mention it here real quick. This part right here is the electric motor. This just takes the electricity in and turns it into RPMs. This part back here, as an assembly, we call this the wet end. And the reason why it's the wet end is because it's the part that actually has the water going through it. The wet end consists of the pump housing, which is usually two pieces, the impeller, which, for lack of a better term, think of it as a little water wheel. Have you ever gone to one of those historical places where they have one of those old mills where there's a wheel that is turned by the flow of water? Well, basically, this is like a water wheel in reverse. The impeller is turned by the motor and throws the water. This design is called a centrifugal pump because it uses centrifugal force to literally throw the water out. This housing, two pieces, the impeller, and the shaft seal. The shaft seal is a mechanical device that has the responsibility of allowing the motor shaft to go into the backside of the wet end and rotate the impeller, while at the same time keeping the water from coming out of the back of the pump assembly. And the shaft seal is a multi-part component. and we'll get to that once we get that apart. But here's all you need to know right now. Pump housing, motor, and what we're looking at down in here, which I'm going to zoom into in a second, this is where the shaft comes out of the front of the motor and goes through the back of the housing. This gray plastic you see right here that's all cracked, this is actually the back end of the impeller. So what's happened is water has been leaking out of this pump because of a bad seal. The seal lets the water get by. The water gets on the steel shaft of the motor, which is not stainless steel, it's not treated, and when the water comes in contact with it, it corrodes or rusts that steel shaft. In fact, it happens a lot quicker than you might think, because in many spas, the chemicals that are used to sanitize the spa, which are necessary, are also oxidizers and highly corrosive. So what happens is the water leaks on here, rusts the shaft. The shaft actually increases in diameter because of the rust, and it actually causes the back side of the impeller to split. That just makes things even worse, and then your leak gets much worse. Long before it got to this bad, in other words, long before it was looking this ugly, water had already been leaking out. And in some cases, what will happen is the water will damage the bearing that's inside the motor assembly in the front. When that bearing gets damaged, sometimes it'll start making noise. So one of the key indicators that you have a pump that is getting ready to fail is if you notice a much louder than normal sound out of the pump, but the pump still operates. I would describe it as a lot of extra high-pitched, high-frequency noise in the sound of the motor that's normally not there. Sort of like a screeching noise that's pretty consistent when the pump is running. That's possibility number one. Possibility number two is if you let that go long enough, or sometimes it skips the part where it starts making noise and it goes right to the bearing locks up. When the bearing locks up, your symptom's going to be different. You're still going to have a loud noise, or possibly a loud noise coming out of the pump, but it's going to be a loud hum, a very distinctive humming noise, and you will have no water pumping. So you'll have no jet action, but you'll hear a loud pump. a loud hum. And that hum tends to come and go, and I'll explain that in a moment. What happens when the bearing locks up and the motor is not allowed to turn? Now, all of that electrical energy that the motor is using is not allowed to turn into mechanical energy. And that energy has to turn into something else, and it turns into heat. And it causes the motor to get abnormally hot. There's a safety feature built into the motor. In the back of the motor, there's actually a device. It's called a thermal cutout. And what that is it's bolted to the frame of the motor. And if the motor temperature gets too hot, that thermal cutout will actually, it's got a little switch inside that will open. You still have the voltage coming in at this point here from the controller, telling the pump to run. The pump, because of its internal cutout, de-energizes the winding. So then all the noise goes away. Then the pump starts to cool. That device is auto-resetting. So when the temperature of the pump housing drops to a certain point, that little switch will click back in and re-energize that winding and start the process all over again. So what you'll get is you'll get a cycle where it hums, heats up, shuts off, cools a little bit, switch resets, hums, heats back up, and it'll just repeat that vicious cycle until either somebody comes along and hits a switch or something to stop it from stop the voltage from coming in at this point, or the fuse inside the control box or the breaker on the house supplying power to the spa can trip. Well, fuses don't trip, fuses blow. So inside this control box, there are one or more large fuses that are designed to do nothing but supply power to the pumps. This is what the typical hot tub fuse, the fuse in the hot tub used for the pumps, looks like. This particular one is a 25 amp. It's SC-25 means it's a 25 amp. It's very important that you get the correct size fuse, both in amperage and physical size. Any fuses you see inside of a hot tub that are glass and are clear, where you can actually see the filament inside the fuse, is not going to be the type of fuse that's used for running one of your motors. Those fuses tend, if they are present, tend to be only used for light systems, and occasionally if you have support for a stereo system or some other auxiliary type of device like that. Even the air blowers tend to use a fuse that may look like a glass fuse but is white in color. It's a ceramic fuse. These are actually, I forgot what these are made out of. They're made out of some sort of almost like a fiberglass. But anyways, that's why these fuses tend to run like $6 to $8 a piece. If you find yourself having to replace this fuse, if you replace this fuse and it blows right away again, more than likely you've got a bad motor. Sometimes they're orange and a little bit smaller in size. This is from a different brand of hot tub. So this pump is locked up. So I can't show you what it sounds like when the bearing is bad, which this one never had any bearing noise before it locked up. So we're just going to go ahead and pull it out. So in case you're wondering, what this one did was right after it locked up, it blew that fuse inside the control box. I didn't even bother replacing the fuse and thinking, oh, it's just going to work again, because I took one look at that area of the impeller, what I could see sticking out of the back of the pump housing, and knew that we had a pump issue. In order to remove the pump assembly, we've got to disconnect where the water comes in, which is the intake, which is usually a large nut that we unscrew. We being me and the mouse in my pocket. Where the water comes out, the discharge, okay, which is that one back there. I already unscrewed it, so I pulled this up. And then on many pumps, there'll be this little auxiliary line right here. This auxiliary line does a couple of things. One of the things it does is it helps purge air out of the pumps when you first fill the spa. The other more important job it does is in cold weather climates, it ensures that water continues to circulate through a pump that's not running, heated water, so that ice can't form. Because the pumps are usually in the equipment compartment in an area that's not fully insulated, so they're exposed to the elements. What can happen is, if you have a pump that's on the back side of the spa or over in a corner where it's nowhere near, if it doesn't have the job of actually moving the heated water through the spa, and nobody's using the spa, and it's, you know, January and the temperature outside is 5 degrees, well, we don't want that pump to get too cold, so we run a little bit of water through it using this little line. And you want to be careful, because these have a habit of let me get the correct tool. These plastic fittings can get brittle with age, and it's easy to accidentally crack one off. So the temptation here is to try and wiggle this to get this off the bar, but what will happen is I'll probably end up cracking that if I do that. So I'm going to get a thin-bladed screwdriver and stick it in here and help work that off. Sometimes in cold weather it's really hard to get these off, and you can heat them up a touch with a hair dryer and it helps. That one wasn't too bad. You can see how that kind of bell-shaped, so I might have a problem getting this to reseal. One of the things I could do is, if I change this spring clamp to a actual hose clamp, the style with the screw on it that tightens down around it, it'll solve that problem. Sometimes you can also cut back to more hose. In other words, I cut this bell-shaped area off, but definitely I would have to heat this hose up. This hose has become what I like to call plasticized. Kind of has lost its elasticity in areas. But anyways, let's get this out. Just want to mention a couple things that are unique to Jacuzzi and Sundance and some other manufacturers. In order to take this pump out on this spa, you have to drain the spa. Well, let me qualify that. Many spas have what are called slice valves or gate valves that you can close in the plumbing that allow you to shut off the flow to the pump, with the exception of that little line that I just disconnected. So what you can do is you can disconnect that little line, find something to plug it off, shut the valves, and you can leave the spa full when you change out the pump. Jacuzzi and Sundance, Hot Springs, many of the high-end manufacturers actually, they decided that they would omit those valves altogether. Some say that they did that because they just didn't want to spend the money on the valves. I actually think it's because they believe that the valves are problematic down the road. And I have seen those valves over time. I've seen them leak. But the most common issue with the valves are that they actually stop sealing 100% when they get old. So they end up being kind of pointless in the end. Also, if you keep on top of your water chemistry, these pump seals and pumps tend to last a long, long time. So I believe that the manufacturers that don't have valves in the plumbing, they're probably going on the assumption that it should be years between services. So you're going to be draining and refilling your spa regularly anyways. So it shouldn't be that big of a deal to drain and refill the spa in order to replace a pump. Because of the design and the way that this particular one is in here, it's a real pain in the butt. The cord here going over to the control box is a little short. So what I'm going to do in order to get this pump out is I'm going to disconnect the wire going to the pump now. It goes without saying, again, because for safety reasons, the circuit breaker is completely off. I can't do this with power going to the hot tub. It's too dangerous. It doesn't matter if no one's turning on this pump currently. What if the system decides to turn it on for some strange reason? Maybe to run a filter cycle or a pre-purge before a filter cycle, or I don't know, any number of reasons. Safest way to do it, the main breaker is off. Two basic ways to get into the back of the motor to where the electrical connections are for the wires. On the Century, A.O. Smith, Magnatech motors, you tend to have a plastic cover like this with a nut right here. I'm sorry, a 1/4 inch screw. On the Emerson and many of the other manufacturers, the access is just a little metal plate with 2 screws. You loosen one screw, you take the other one off, and that little plate comes off, and you can get right in there and see the connections. And that's all you can see on those. Whereas on this one, when we open it up and get this cover off, we can see the electrical connections. In addition, we can see the start capacitor. So now I'm going to loosen the strain relief on the ones that have the metal cover instead of the plastic housing. On those, oftentimes the strain relief doesn't exist, and what you have is the cover actually acts as a clamp to strain relief the outer insulation. If you are not experienced and not sure of yourself, or if your motor's really old and you don't have a wiring diagram, by all means, make a note of where the wires go by color code. The color code for hot tubs is fairly standardized, with the exception of a couple manufacturers. But almost all the manufacturers rely on using the white wire as a neutral, or in this case, because it's 220 volt, one side of the 220 volt line, so we'll call it L2. Black wire is the low speed winding, red wire is the high speed winding. In other words, when this motor is on low speed, there'll be 220 volts across these two. On high speed, there'll be 220 volts across white and red. The green wire is the ground, and oftentimes it's not a spade connection like this because they want a more positive connection, so it's screwed directly to the housing. Sometimes it's a tight fit to get these to all get through here, so what I usually do is try and get one of them out first separately, and that usually opens things up so the other ones will all fit. It weighs about 35 pounds. If you look at the pump from the front, you'll notice that this actually is coming up at an angle. This is the discharge. This is the suction. Water goes in here, it's thrown out here. So it's at 45 degrees. This is unusual. Let's take a look at the pump on the left-hand side of the same spa. That one, you can see the discharge is actually facing towards the rear. If we looked at that one from the front, we had it out and we're looking at it from the front, that would be 90 degrees to the vertical. If we unloosen this housing and rotated it 90 degrees and reattached it, that would be facing straight up or vertical. That would be top discharge. So side discharge and top discharge are the two standard ways that 99% of the manufacturers on the market have their hot tub pumps oriented. Jacuzzi and Sundance did this thing where on some of their spas they required this design. So that necessitated the ability for the pump to be oriented halfway between top and side discharge. So if you look at the motor, this is what's called a through bolt design. There's actually a very long skinny bolt. The head of it's way back here. It goes through the whole housing and threads into brass inserts that are in plastic injection molded into the plastic housing. So we have to have these positions of the bolts oriented in a way to allow this to be at a 45-degree angle. That makes this housing not unique. All this is a regular housing that's rotated up. What it is it's rotated up 45 degrees, so the motor is unique. So the problem this presented for the manufacturer over time was, if you have two different versions of this, one that's a 2-speed motor and one that's a 1-speed motor, now all of a sudden you've got a situation where your dealers have to stock several different variations of the same pump to be able to cover all of the possible repair scenarios. So what they did was they realized that, hey, we've got to have a better way to deal with this. So they came out with a motor that actually does not have this foot right here, this mounting foot, welded on at all. It's just a motor housing. And then they came out with a special motor mount, which is basically this part right here with a metal clamp on it that allows you to mount this motor with no foot on it into the clamp, rotate it to whatever orientation you need, and then clamp it. I know initially when they came out with them, the bracket was a separate part number. It was ordered separately. The reason why the bracket's not included automatically is because if you're already replacing a newer style, you can reuse the bracket and just replace this part. But we're getting ahead of ourselves. We don't even know yet whether or not we have to replace this. I know what you're thinking. You're thinking, hey, Steve, you said it was already locked up, that it doesn't spin at all. It must be a bad motor. Not necessarily. I've actually seen cases where once this bad impeller and pump assembly was removed from the motor actually was able to turn. Let's see whether or not we're buying a complete pump assembly with an electric motor or whether or not we can save this thing. So what I got to do is I got to figure out whether or not the reason why it's humming and not turning is it locked up because the impeller's locked up, or is it locked up because the bearing in the motor is seized. So I'm going to remove these screws so I can take this front faceplate off the pump. I've got to remove this impeller from the shaft. The way that this is attached to the shaft is at the end of the shaft it's threaded. Because plastic threads wouldn't work, what they do is they have a metal piece, usually brass, that has threads, female threads in it, that when they make the impeller, it's plastic molded inside here. That is what the threads on the steel shaft of the motor actually thread into. But it's not uncommon for them to get seized. This impeller is in such bad shape and it's all split and broken anyways. I'm not interested in trying to save this impeller. In fact, you can plainly see the big old split in the impeller. So what I'm going to do is I'm going to break off these hunks of plastic. That's all rust. Now with that off, I can actually sneak a pair of vice grips into there. Now the end of the shaft of the motor has a slot in it. So you could stick a large screwdriver in there and hold it with that. But I find it's difficult to keep that screwdriver on there squarely. It tends to want to slip off. So rather than have to deal with trying to reach back here and keep that screwdriver from falling off, I prefer this method. Now on some motors, what they do is they actually have on the end of the shaft, they have flat spaces on the end of the shaft. Instead of it being round, it'll have flat spots that'll allow you to find or to use a wrench on there to hold it. That's much better. But on this one, it's just a screwdriver slot. So we're going to go with, instead, we're going to go with the vice grip trick. And the great thing about the vice grip trick is the vice grips are going to be held in place by the housing. So once I get it clamped, I want to get it as tight as I can. All right. So now, see, that can't go anywhere. So now it's just a matter of turning the impeller counterclockwise. Sometimes an extra set of hands to hold the motor housing is helpful. The other thing you could do is you could put a strap wrench on here. Sometimes you need a strap wrench on here. All right, it's a lot tighter than I was hoping, so we're going to try the strap wrench now. There we go. Now, I've actually had situations where these were on so tight that what I ended up having to do was I get screwdrivers in here and basically break this impeller into pieces. I break the plastic, and then I break off the plastic far enough so that the bulk of this is removed, and then I'll take this rear housing off. The rear housing is held on to the motor. This is a through bolt design. So what we've actually got is we've got 1/4 inch heads on very long skinny bolts that go through they go through this back cap of the motor, through the entire main body of the motor, through this cap, front cap of the motor, and into the plastic here where there are little brass inserts. So loosen these 4 up, remove this. Once I have that off, you can usually break the remaining plastic off and actually reveal that brass nut that's buried in the plastic. Once you reveal that nut, it almost always has flats on it like a regular nut, so you can put a wrench on there. And then again, you're holding it now with the vice grips, put a wrench on there, and I can almost guarantee you, at that point, it'll come off. I lucked out. This actually came off without me having to bust this completely apart. So here's the back of the impeller. So normally this plastic is supposed to be intact and come out as a sleeve, and then on the sleeve we have this device with this spring. This is 1/2 of the shaft seal. I usually just grab this and twist it with channel locks. So just give it a twist. The seal has a couple of different components to it. It comes as an assembly. This is a metal, can't really tell because of the rust, but this is actually a metal cap that's stuck on there. And then what's behind or under this metal cap is a little rubber seal. So that's what keeps water from being able to get down behind this and migrate around. But what actually keeps the water from traveling along the shaft of the motor and coming out the back there and causing the problem that we have where it corroded the whole damn thing is this 2-piece seal. This is one of the sealing surfaces right here. This white area right here is the other sealing surface. This is a ceramic typically. That is pressed into this well on the back plate of the pump housing into a rubber cup that actually acts as the device that seals this. So at this time, to make my life easier, since I'm going to have to do it anyways, I'm going to remove the back half of the pump housing from the motor. With the impeller off, it's just a matter of undoing these 4 long 1/4 inch screws. So a 1/4 inch nut driver. I'm just going to take one of these. You don't have to take these out to do this, but I'm just going to take one out to show you. See, it's a very, very long, skinny screw. Just make sure you're only unscrewing the 4 heads of screws that are actually for the long through bolts. You can usually tell by just looking down sighting down the frame of the pump. There we go. This is the back of the pump housing. You can actually see inside there are little brass inserts that are molded into the plastic legs here. And all of this white staining you see here, this is all telltale signs that this has been leaking for a while. What happens is the water leaks out along here and it evaporates and it leaves behind the chemical residue of the chemicals used in the water. In this case, this particular spa is using granulated chlorine. With everything removed, I can now spin the shaft and I can listen. And it actually doesn't sound very bad at all. It doesn't sound like a bad bearing. This thing right here, which is pretty much destroyed, this is referred to as a slinger. When this when this is intact and working, what it's supposed to do is it's supposed to be the last line of defense to protect this bearing that's right behind this area here. What happens is as the water leaks out along the shaft and it hits this as the motor's running and this is spinning, it will sling off of here and go flying off, and it'll create a telltale stain right in a perfect line right along where this is slinging the water. Now I need to make a determination on this motor, because if this motor ends up being good, I mean, yeah, this shaft looks pretty nasty, but you know what? We can clean that up and we can completely salvage that. But we got to find out, why wasn't this motor spinning, or was it just kind of a fluke or something that maybe it was, the impeller was jammed at one point, blew the fuse, don't know. Anyways, we got to figure out what's going on with this motor, so we're going to have to get some electricity to it. If the motor does prove to be good, then that's going to be really good news for me, because then it means all I've got to do is get an impeller, a replacement seal, and then for good measure, actually on the back here, this O-ring right here will replace. And those three parts, the seal, the impeller, and the O-ring, are a lot less money than the complete pump assembly with the housing and everything. So normally, if I were on site working on this and I didn't have the luxury of actually being able to bring this back to my workbench, what I would do is I would reconnect the wires from the control box on the hot tub to the pump and use the control box to actually turn on and off the pump to hear this, to get this to spin and see what was going on with it. Again, I can't stress enough, this is a 230 volt pump. You're dealing with high voltages, a lot of danger. If you don't know what you're doing, by no means should you be attempting to mess around with this. Alright, so I've got it wired up. This is a 2-speed pump, so the wiring diagram on the side here actually shows 3 connections. It doesn't show the ground connection, which is usually just to the case. It shows the 3 connections for the actual motor windings and circuit. So we've got, they're actually labeled, and it's 2, 3, and 4. 2 says line, and then 3 says high, and 4 says low. So what that means is that number 2 is common for both windings. So we're going to have one of the two 220 volt legs is going to go to line. The other leg, if it goes to 3, that will be the high speed winding. And if it goes to 4, that'll be low speed. We do not energize both at the same time. It's one or the other. We're going to use low speed. I want to see if this motor will start and run on low speed the way it should. There's only the slightest amount of bearing noise, nothing to indicate an abnormal situation. I think that motor is going to be fine. What I do want to do though is I don't want to take it at face value that the motor is absolutely good on the first try. What I'm going to do is I'm going to de-energize the circuit, allow the motor to spin down to 0 RPM, and then try and restart it again. And I'm going to repeat that several times. If at any point it fails to start and hums, I'm going to suspect that I've got something going on in the motor. Either a bad centrifugal switch that's sticking or something else. That distinctive clicking noise that you hear when the motor is de-energized and as it starts to lose RPMs, that's the centrifugal switch in the back here that actually is snapping back into the start position. So that's normal, that noise. And that scraping sound you hear as it's spinning down, that's also normal. That's actually the disc, which is like made out of some kind of a, almost like a phenolic material that is actually rubbing, and that's normal. So this is all normal noise from this motor. So what I'm going to do now is I'm going to clean this shaft up. There's a couple of different ways you could go about cleaning the shaft on the motor. And I actually like the lazy way, which is I let the motor do the work for me. So what I'm going to do is I'm going to take a file. So I'm just going to hit it with a file quick, and then I'm going to use some sandpaper to finish cleaning it up. Yeah, that shaft was in pretty rough shape. It's actually got a taper to it now. That's how much metal has been removed. Not by me with that little bit of filing. That was metal that had converted into rust that was flaking off. But the important thing is that down here at the end, it looks like it's in a pretty decent shape. This started its life as probably a 1/2 inch diameter shaft, and it's well, it's about 10 thousandths under a 1/2 inch at the end there, but in here where it clearly looks smaller, it's it's about 55 thousandths under. But in the world of pump impellers, that's actually still serviceable. So I've got to get a replacement impeller and seal. Now the seal, I happen to know on this particular model that this is a PS201 seal. PS for pump seal and 201 is the designator. And then there are actually a couple of different variations of the seal, and they have a very cheap seal, and then they have like a medium grade seal, and then a very high end seal. I usually go for the medium grade because the medium grade is significantly better than the cheap seal, but I don't believe that the premium top of the line seal is that much better to warrant the additional jump in price. So you do what you want, but the most important thing is that when you order these seals, if you can order the seal as a generic seal, for instance, if I go to Google right now and I put in seal PS201, I'm going to get a bazillion choices that are going to come up for places where I can get the seal and a whole bunch of different prices. So when I look at the actual materials that are being used in the seal, and so I can make fair comparisons, apples to apples, so to speak, I can usually find really good prices on these seals at some vendors. Whereas some vendors will go out of their way to gouge you on pricing on seals, especially if you allow yourself to be at the mercy of them to identify your seal. For instance, if you go to some of these sites and you just try and tell the website that, hey, I've got this particular pump. You go here and you look at your part number on the pump and you say, I need a seal for this pump. Next thing you know, they might be trying to charge you $40 for a seal that you could get elsewhere for $12. So keep that in mind. As far as identifying your seal, well, basically what you need to know is you need to know the construction of the seal, basically how it's made. And there's some, I'm not going to get into that because there's a lot of good graphical representations on these websites that sell seals to basically explain how to identify your seal and also how to size your seal. So it's nice if you have a pair of calipers like these. They don't have to be anything as fancy schmancy as these Mitutoyos. For $10 you can get yourself a set of digital calipers from Harbor Freight, Pittsburgh Tool branded, and they're going to be good enough for doing something like this. You can even, if you've got a really good eye, you can even make a measurement on a seal using a scale like this. Or you can even do it with a lousy plastic set of calipers. These actually are, even though they're plastic, they're actually decent. They're made in the USA. But I just kind of wanted to grab these to illustrate the point that they do make plastic calipers. This one is a dial caliper. You don't even need that. You can get by with what they call a vernier caliper, which here's a inexpensive metal vernier caliper. So this is a little bit trickier to read, but it's not too difficult to figure out, you know, what 3/4 of an inch is. And if you don't remember, all you do is you take the numerator, divide it by the denominator, so 3/4. I'm going to take 3, divide it by 4, and it's going to come up to 0.750. And what that means is it's a 750 thousandths dimension. So on a caliper like this, I can go to where the 7 is, and if I know that it's falling between this, halfway between the 7 and 8, chances are that's 750, so it's a 3/4. All right, so just keep that in mind, which this is.